This video is for Math 112 Trigonometry, and this video is on section 1.4, which is the first of two sections on applications. So before we get started looking at problems, just two things I want to talk about. Well, three, but I'll hold off on the third one for a minute. The first two are angle of elevation and angle of depression. Okay, so angle of elevation, this is something, if you're looking up to something from lower down, that's where your angle of elevation is going to be. Okay, the angle of depression is if you're up on top of something, looking down, the angle of depression is found in relation to a horizontal line that coincides with the elevation that the observer is at. Okay? And in the textbook I talk a little bit about, because of the properties of geometry, these two angles here and here are what are called alternate interior angles, and they are congruent to each other. So in most cases, the angle of elevation and the angle of depression will be the same, assuming that your points are the same. Okay? And so that comes up in a lot of problems, angle of elevation and so forth. It's a good way to measure things indirectly. Okay, well, let's take a look at some of these problems for section 1.4, starting on page 37. Let's see here. Problem 2. We've got a helicopter 700 feet in the air. So let's see here. Here's the helicopter. And we're going to say that that is 700 feet. Okay. Helicopter 700 feet in the air measures the angle of depression to a landing pad as 24 degrees. Okay, so angle of depression means it's going to be coming down like that. This angle right here then is 24 degrees. Now I could make the triangle over here, right, and call this 700, and this would be a right angle, or I can put my triangle here, with this being 700 feet. This distance is not known, this distance is not known, but we know that angle there is 24 degrees, and we know that height there is 700 feet. How far from the landing pad? How far is the landing pad from the point directly beneath the helicopter? So this is what we're looking for. Okay. All right. Well, if this is our angle, then we've got the side opposite and we're interested in the side adjacent. So that's, to me, says tangent. Tangent 24 degrees then is going to be 700 over x. So we can multiply on both sides by x and divide on both sides by the tangent of 24 degrees. And so x is going to be 700 divided by the tangent of 24 degrees. Let's get a good approximation for this. Let's see here. First off, make sure that your calculator is in degrees. Okay, and then we'll do 700 divided by the tangent of 24 degrees. And so this comes out to be about 1,572.2 feet. Oh, yeah, to the nearest tenth. Round answers to the nearest tenth. Okay. Well, that's good. Let's see here. Problem 4. A 275-foot guy wire is attached to the top of a communication tower and then makes an angle of 53 degrees with the ground. Okay, so let's see here. Here's our tower. makes an angle of 53 degrees with the ground. The wire itself is 275 feet long. Let's see here. How tall is the tower? So I've drawn this because these towers frequently have, you know, sides that flare out to help support it, but its height is going to be this perpendicular right here, and that's going to make a right angle, and then that's what we're going to be interested in. Okay, so here's our angle, 53 degrees. The side opposite is what we're interested in, and we've got a value for the hypotenuse, and so that says to me the sine ratio, so sine of 53 degrees is going to be h over 275. So, opposite over hypotenuse, cosine adjacent over hypotenuse, and the tangent is opposite over adjacent. Okay, so let's see, all we have to do here is multiply on both sides by 275. So h is going to be 275 sine of 53 degrees. And let's get a good approximation for that. 275 sine of 53 degrees, 219.6, 219.6 feet tall. And that's problem 4. Right. Let's see here. Problem 6. Measure the height of the cloud cover in an airport. A spotlight is shined upward at an angle of 62 degrees. So this one has a diagram already drawn. Okay. An observer 1,000 feet away measures the angle of elevation to the spotlight to be 36 degrees. This distance right here is 1,000 feet. Okay. And that is h. Let's see here. So, find the height of the cloud cover. All right. Well, let's see what we've got here. Is there an easier way to do this? Now, some of these problems, you know, we could use trigonometric formulas from later in the textbook, but I'm trying to stay away from that and only use the information that we've learned so far. So I think what I'm going to do here is I'm going to call this x, and I'll call this 1,000 minus x. It's a very common mathematical trick. Okay, if you know that something is a particular length, then when you cut it into 2 pieces, right, if this whole thing here is 1,000, then if we cut it into 2 pieces, if this one's x, then this one is 1,000 minus x, right? If this one's going to be 100, this will be 900. If this is 300, this will be 700, and so on, okay? The idea here is that if I call this y, x plus y has to add up to 1,000, therefore y is going to be equal to 1,000 minus x, okay? All right, let's see here. So if we set it up like that, then we'll have the tangent of 62 degrees being h over x, and the tangent of 36 degrees being h over 1,000 minus x. Okay, well, now that we know that, what can we do? Well, let's let's multiply here on both sides by x. So that says h is x times the tangent of 62 degrees. So now let's take that and put that into the other equation for h in place of h. So tangent 36 degrees is going to be x times the tangent of 62 divided by 1,000 minus x. Now let's clear out this denominator, multiply on both sides by 1,000 minus x. So this is 1,000 times the tangent of 36 minus x times the tangent of 36 degrees equals x times the tangent of 62 degrees. At this point, I would probably approximate these values. You can hold on to these tangents and solve for this in exact form if you want to. I'll come back to this maybe in a few minutes and talk about doing it that way. But for right now, let's see. Let's go ahead and get some good approximations. So 1,000 times the tangent of 36 degrees, 726.54. And then minus just the tangent of 36, that's going to be 0.72654. Alright, because that 1,000 is just going to move that decimal point over. And then over on this side, the tangent of 62 degrees, and that gets an x, 1.8807x. So let's add this to both sides, 72654x. So 726.54. 1.8807 plus 0.72654, 2.6072, 2.6072x. Okay, so then we'll do 726.54 divided by 2.6072, and what do we get here? X is going to be approximately 278.67. 278 and about 2/3. Okay. Did I answer the question? That's the real question here. Oh no, find the height of the cloud cover. See, I found x. We wanted to know what's h. Well, h is x times the tangent of 62 degrees. So let's take our x, just sitting right here on the calculator, and then I'll just go times tangent 62 and 524 feet. H equals approximately 524. If I round to the nearest tenth, it'll be 0.1. Okay. Let's see here. Now, if we come back here, it's the same process. We're going to add this to both sides. And so that'll give us 1,000 tangent 36 degrees equals x tan 62 plus x tan 36. And the trick here, this is very much like solving one of these logarithm problems that we do in Math 111, where you factor out the x and then you divide through by tangent 62 plus tangent 36. So, x is going to be 1,000 tangent 36 divided by tangent 62 plus tangent 36. So there's our exact value. Let's see exactly what it is. It should be 524.1. So let's see what we get. 1,000 tangent 36 and then divided by tangent 62 plus tangent 36. Oh, 278.66. Okay. And then if we plug that back in here, times tangent 62 524.1. Okay, good. Calculating this, you have to be really careful with your parentheses if you want to approximate this on the calculator. So if you get something other than the 278.66, which is what you should be getting, it's probably due to misplaced parentheses. Well, that was kind of an interesting problem, and believe me, these trigonometry problems get even more interesting. Even, you know, when we get done with this textbook or any elementary trigonometry textbook, I can tell you, I went to a presentation once by a professor at OIT who taught mechanical engineering. So it's all about working with machines. So mechanical engineering, a lot of machines, you may or may not know, have things that spin and an arm that drives something. And so in that spinning, there's a lot of trigonometry that goes on. And I can tell you, those mechanical engineering trigonometry problems are very, very interesting and very complicated as well. All right, let's see here. Let's get back to what we were doing. Problem 8, we've got a small airplane flying at an altitude of 7,000 feet. Okay. Problem 8. 7,000 feet. A car in front and a car behind. Okay, so I was kind of wondering where I want to put everything. So there's the airplane. We know that the altitude here, 7,000 feet. A car in front has an angle of depression of 72 degrees. So that's 72 degrees and that's 72 degrees. I find it a lot easier to work with these triangles down here. So I almost automatically put that 72 in 2 different places at once. Okay, and the car behind the plane has an angle of depression of 48. Okay. So there's our angle of depression, 48 degrees, and that means that this one in here is also 48 degrees. Okay, so it's looking similar to that other problem, except this time we know what the height is. So what do we want to do? How far apart are the cars? All right. Well, in this case, I'll just find x and y and then add them together. All right, let's see here. So we can say tangent 72 is 7,000 over x, and tangent 48 degrees is 7,000 over y. So here, multiply on both sides by x, divide on both sides by tangent 72, and then do the same thing over here. Multiply on both sides by y, and divide on both sides by tangent 48 degrees. So y is 7,000 over tangent 48. Okay, now let's get some good approximations for these and add them together. So 7,000 divided by tangent 72, 2274.4, 274.4, and over here y, 7,000 divided by tangent 48, 6302.8, and 2274.4. So total, the answer to the question, the distance between the cars, 8,577.2 feet, or a mile or so, a mile and a half, right? 1.6 miles. Okay. All right, so that's problem 8. board's getting a little messy. Let me wipe it down. There we go. Okay. Problem 10. Man standing on the roof of a building 70 feet tall. Okay. There's our building. We know its height is 70 feet. Looks at the building next door. The angle of depression to the roof of the building next door is 36 degrees. And the angle of depression to the bottom of the building next door is 65 degrees. Okay. Okay, let's see here. How tall is the building next door? Well, let's see what we've got. Now, if this whole angle right here is 65, and this one over here is also 65, we know that this side is 70. We could find that distance right there. Would that be helpful to us? I don't know. Let's see here. What else? Here's another triangle right here. We know that this angle in here is 36 degrees. Yeah, so then if we know that distance there, x, right, then we'll have this triangle that looks like this, 36 degrees, x, and that side would be the difference between the heights of the two buildings. I'm not sure that we can calculate that height directly. I don't really see any triangles that involve that as a side unless we took this triangle right here, which is not a right triangle. And again, we'll talk about that towards the end of the course. The last chapter in the textbook has to do with triangles that are not right triangles, but we're not really quite there yet. All right, so let's go ahead and use that big triangle where we know this is 70, we know this is 65 degrees, and then we can find the value of x, and then once we know x, we can find the difference in the heights of the two buildings. That'll allow us to find the height of the smaller building. Okay, so let's see how this goes here. What do we have here? Tangent 65 degrees is 70 over x. So x is going to be 70 over the tangent of 65 degrees. And again, that comes from multiplying on both sides by x and dividing on both sides by the tangent of 65 degrees. Okay, so 70 divided by tangent of 65. X is going to be about 32. I'll go with 64 because I'm going to have to use that value in the next problem here. So I don't want to lose too much accuracy. Plus that 4 is not a good number to round with. I always look to round with, you know, 9s, 0s, 1s, 8s and 2s are okay. But when you get up to 4, 5, and 6, it's usually, you're pretty far away from what you're going to be rounding to. All right, now that we've got that, now we can say, all right, now the tangent of 36 degrees is going to be equal to h. Well, I'm not going to call that h because it's not really the height. It's the difference in the heights. So I'll call it d. So that's going to be d over 32.64. Multiply on both sides by 32.64. So, and now here's something I'm going to point out when it comes to accuracy. I worry about accuracy probably more than other people do, but I think it's important. So here's the thing. I've written down 32.64, but I still have the full number sitting right here on the calculator. There's no reason for me to erase that and replace it with a less accurate number. All I have to do is hit the times button, and then it'll say answer times, and then I'll go tangent 36, and hit enter, and there's my answer. So let me show you what that looks like on the calculator. Yeah, so there's the 32 right here, right? I did the 70 divided by tangent 65, and then I wrote it down, 32.64. But then when I hit times, I got this right here. It's going to take that whole value, and in fact, it's not even, it's more decimal places than it's even showing. And then it gives me this answer, and I can say my answer for the D is 23.7. So that's just a piece of advice about using the calculator, and there's no reason to erase the more accurate values and replace them with less accurate ones. So if D is 23.7, then 70 minus that is going to be 46.3. H, 46.3 feet. That's the answer to the question. All right. So it looks like we've got some glare on the board, so try to get rid of that. Okay. All right, so problem 10, how tall is the building next door? 46.3 feet. There we go. Problem 12. All right, so now we've got the next thing that I want to talk about besides angle of elevation and angle of depression. Now we've got this idea of bearing to worry about. And this is frequently used in surveying. We're going to use it for any problem that involves direction. Just so that we get familiar with the concept. So if you see a property description, a lot of times, if you read in the paper, sometimes they include property descriptions, and they're given frequently in terms of these bearing instructions. Okay, so there's a north, south, east, west quadrant. The idea here is that if you have an angle that's over here, let's say this is 27 degrees, then this would be called 27 degrees east of north. And it's kind of confusing because they put the n first, but in any event, that's saying you start at the north direction and you rotate 27 degrees to the east of it. Okay? If you had something like, let's say 42 degrees west of south, then that would be over here. 42 degrees west of south. Okay? All right. Let's do some problems, and hopefully this will become more familiar to you. But it's all based on that north, south, east, west quadrant. Okay, so that, if you've never worked with that before, that's something that's important to get comfortable with. All right, problem 12. Man walking in the desert travels 1.6 miles, 57 degrees east of south. All right, I should have erased that other one. Let's see here. North, south, east, west. 57 degrees east of south. It's going to be like this. 57 degrees east of south. And they go 1.6 miles. I'll make this length right here and call that 1.6 miles. He then turns 90 degrees and continues walking for 3.2 miles in the direction 33 degrees east of north. So here's the thing, we have to make another north, south, east, west quadrant because our new coordinates are given based on that position right there. And he walks, let's see here, 33 degrees east of north. 33 degrees east of north is going to be there. 33 degrees inside there, and walks for 3.2 miles. Okay, so that's going to be basically double that length. 3.2 miles. At that time, how far is he from the starting point, and what is his bearing from the starting point? Okay. Oh, there is going to be our distance that we're interested in. Now remember the problem said he turned 90 degrees there, right? So let's see here. We've got to figure out some angles. What can we do? Because we've got this triangle here that's looking kind of like this, where this is 1.6, this is 3.2. That's a right angle. Let's see. We can use the Pythagorean theorem we can use to find the distance. So let's go ahead and do that. So this is C. We'll say 1.6 squared plus 3.2 squared is going to be C squared. All right, 1.6 squared, 2.56, 3.2 squared, 10.24, 12.8, and then we'll square root that, 3.577 approximately. Called it D here, but I called it C over here. Let's be consistent. Okay. All right, so now we've got all three sides of the triangle. We could start going and finding some angles, right? Because we've got an angle here, and then we've got a second angle up here. Let's see, what do we really need to know? What we really need to know to describe the bearing of this point, it's going to be this many degrees east of north, right? We need to fill in that value. We don't know what it is. Well, one thing we can do is we can find this angle in here, right? And then these three angles are supposed to add up to 180, right? Because this is 180 degrees right here. So, so this angle I'll call theta. There's theta. And then we know that the tangent of theta is going to be 3.2 over 1.6, which is really just 2. So we want to do theta is inverse tangent of 2. And your calculator is pretty sophisticated. You can use 3.2 divided by 1.6 and find the inverse tangent of that just as easily. Let's see here. So we want to do the inverse tangent of 2, and that says that theta is going to be approximately 63.435 degrees. I'm kind of going a little overboard on the accuracy there. We could have just called it 63.4. Because now really all we have to do is, if I call that angle alpha, then we know that alpha plus 63.4 degrees plus 57 degrees, that all has to add up to be 180 degrees. Okay. There may be an easier way to go about doing this, but I'm not sure what exactly that would be. So let's see here. So 63.4 plus 57, what is that going to be? 120, yeah, 120.4. And then if we do 180 minus that, that should be about 59.6 degrees. There we go. Alpha 59.6 degrees. Okay. 59.6 degrees. So 59.6 degrees east of north, and the person is 3.58 miles from their starting point. If we rounded it to the nearest tenth, it would be 3.6 miles. Okay, that's kind of an interesting problem. Let's see here. Problem 14. Raymond, Washington is 22 miles due south of Aberdeen. I've fudged a little bit on whether or not it's actually directly due south, but for our purposes, we will assume that it is. Okay, so Aberdeen is here, and we'll say Raymond is due south 22 miles. Okay. Monsanto is due east of Aberdeen, again, approximately. But for our purposes, we'll assume that it is exactly due east. And 26 degrees, 34 minutes east of north. Okay, so here's our little north, south, east, west thing. So east of north like that. And this is saying that that's going to be 26 degrees, 34 minutes. This is a right angle because this is due south and that's due east. And now we've got a pretty good looking triangle here. How far is Monsanto from Raymond? That's what we want to know right there. Okay. Well, let's see. We can use the cosine, right? We've got the adjacent side and the hypotenuse, so we can say the cosine of 26 degrees 34 minutes is going to be 22 over c. Our calculator, I usually don't use the DMS notation when I'm finding sines and cosines and so forth, just because it's kind of cumbersome. So let's do 34 divided by 60. That's 5.6 repeating. So I'm just going to type in, 0.56 repeating. 0.56 repeating. So when I calculate with that, I'm just going to hit the 6 button a whole bunch of times when I type that in to get a value for it. Okay, so multiply on both sides by c, divide on both sides by cosine, 26.56 repeating degrees, and there's our answer. And so let's see here, 22 divided by cosine 26.5, 6. A bunch of sixes. And so C is going to be approximately 24.4 miles from Raymond to Monsanto. Okay. And let's see here. That's all we needed to know. Okay. Last one here, problem 16. A boat travels on a course bearing 17 degrees 10 minutes east of north. All right. So there's north, there's east, and there's 17 degrees 10 minutes east of north for 10 miles. All right. So let's see. Let's erase some of this right here. Call that 10 miles. How far north and how far east is the boat from its starting point? Okay, here's the starting point. So let's drop a perpendicular. I'll use the red pen to try to get it to stand out here. So this is how far east, this is how far north it is from the starting point. So what we've got is we've got this little triangle here. East, north. Now we know that this angle in here is 17, it's 0.16 repeating degrees. That 10 minutes, 10 out of 60 is going to be 0.16 repeating. So we could just subtract that to get this angle in here. It's also, this angle in here is going to be 17.16 repeating degrees, which means that this one down here, this is going to be what, 72.83 repeating degrees, all right? Let's see, is 009, yeah, okay. All right, oh yeah, and we know that that side is 10 miles, right? Because that was how far they traveled, it was 10 miles. Okay, so let's see here. We could say the sine of 72.8, this is 50 minutes, 83 repeating, is going to be n over 10, and the cosine is going to be e over 10. Okay, so let's go ahead and calculate those. Let's see here. N is going to be 10 times the sine of 72.83 repeating degrees. So 10 sine 72.83 is 9.55. 9.55 miles is how far north they are. East is 10 cosine of that angle. So let's see here. 10 cosine 2.95. 2.95 miles. So there we go. 2.95 miles east, 9.55 miles to the north. And that's all we're being asked for. So there they are. So if we wanted to round these to the nearest tenth, I guess this one would be 3.0 and this one would be 9.6. All right, so that's it for section 1.4. We'll come back and look at these same ideas in section 1.5 with a little bit trickier algebra, a little bit more like that clouds problem, where we had to set up two equations and do some substitution. So that's what we're going to be looking at in section 1.5. So that's it for this section. If you have any questions on this, please let me know. Thanks.